We've seen a lot of activity, especially around the Ring of Fire, with earthquakes and volcanic activity. And we wonder how that is so prevalent, especially increasing. Now, Earth's orbital cycles may have something to do with that. Earth's orbital cycles may trigger peaks of volcanic eruptions. This is by Scott Johnson. He's a geologist, and he's writing this article on Ars Technica. He says there are 41,000-year cycles in the Earth's tilt. And the Earth's tilt matches up the peak volcanic activity. So the Earth tilting, we're doing something like that is happening now with our magnetic poles moving, and a lot of people saying, well, perhaps the Earth is also shifting. It certainly does move when we have big earthquakes. It sort of tilts a little bit off its axis. But there's a 41,000-year cycle in the Earth's tilt, and it matches up with peak volcanic activity, they say. Over the past couple of million years, a rhythmic pattern of climate changes has been driven by the cycles in Earth's orbit. These cycles affect the sunlight reaching the Earth, and it alters seasonal patterns, and it leads to growing and shrinking of the ice sheets. And as we know, we're going under that effect now because of the fact that the glaciers in the north are melting, the ice sheets in the south, in the Antarctic, are melting, and that weight of the ice on the poles is being relieved, which means like it's as if you're pressuring a balloon on both ends with your hands. If you relieve the pressure, the balloon changes shape, and that's what happens to our Earth, which means the tectonic plates shift and move. So, over the past million years, this rhythmic pattern of climate changes drive the cycles in the Earth's orbit. These cycles affect the sunlight reaching the Earth, altering seasonal patterns, leading to growing, shrinking ice sheets, and the changes echo throughout the Earth, from atmospheric and ocean circulation to ecological responses, even to erosion and sediment transport. But could the cycles have affected the volcanic eruptions? Well, what do you think? When you have tectonic plates moving, they definitely affect volcanic eruptions. A new study published by Geology argues that they did. Previously, researchers noticed correlations over limited time periods and regional scales, but the new work extends this to a broader picture. It appears to show a pretty strong link. To get long records of volcanic eruptions, the researchers used marine sediment cores from around the Pacific Ring of Fire. And unlike on land, where erosion can wash away ash layers, the records in the seafloor sediment preserve the ash from eruptions that occurred upwind of their locations. Errors in the dates assigned to those ashes, which are based on correlating those layers with well-dated ones on land and estimated the rate at which sediment piles up on the seafloor, are difficult to avoid. But the researchers did their best to account for that uncertainty. After pulling together all the eruptions they identified over the past million years, they analyzed the data for cyclical patterns. They find cycles on the same length as the orbital cycles that affect climate, particularly the 41,000-year cycle in Earth's tilt, which shows up most prominently. To ensure this was not a fluke, they artificially generated 100,000 random data sets. Fewer than 1% of the data sets contained a signal as strong as the 41,000-year pattern in the actual data. So why should this be? And they said, after all, the correlation and causation are very different things. There is a plausible connection here that the researchers explore. They explored the stress changes in the Earth's crust that are caused by glacial cycles. In other words, the melting of the glaciers or the piling up. Now, when the climate cools far enough, large ice sheets grow and the sea level drops. And those ice sheets actually depress the crust beneath them. It's like, as we said, you have a balloon and you're pressing on the balloon from both ends, which means that the crust is pressing, is being stressed, which means the tectonic plates have to bulge out somewhere. And again, that means that they have to move, which means volcanic eruption. So those ice sheets actually depress the crust beneath them, which springs back up when the ice melts away. And farther from the ice sheets, great variations in sea level similarly affect the ocean crust. Rise in the sea level and the ocean crust gets depressed a bit, and like a squishy liquid-filled ball or a balloon, pressing down on one spot causes neighboring areas to bulge out somewhere else. So nearby continental crusts like volcanic activity in Central and South America actually pops up a bit when the sea level rises. If the pressure pushing down on a magma chamber decreases as the crust rebounds upward, it becomes easier for the magma to work its way to the surface, leading to an eruption. So in this way, large climate changes could act to loosen the corks keeping eruptions bottled in. To examine that possibility, the term used a simple computer model that simulated crustal stresses over the last glacial or ice age, and zooming in on Central America, the eruption record there correlates pretty nicely with periods where the model calculated changing stresses. And to conclude with, the researchers also looked at the exact timing of the peaks in eruption frequency in relation to the orbital changes, and this is what was amazingly astonishing. For the 41,000-year tilt cycle, the eruption spikes lag several thousand years behind the changes in the tilt and the climate. That makes sense for sluggish crustal responses to changing conditions at the surface, and in fact their model simulation behaved similarly. While the study eruption data is neither global nor perfectly complete, it seems likely that the group has captured a real pattern, and that pattern once again highlights the interconnectedness of Earth systems, which still hold plenty of surprises. So this is something that they have to definitely examine, and they will find a lot of answers there. Maybe they'll also find the exact, well, pretty much exact, how often this occurs. Maybe they'll come to the 3,600-year cycle that we have when Nibiru or Planet X or Wormwood or Planet 9, whatever you want to call it, comes closer to Earth. Maybe they'll find something more cyclical when they do more core samples. So that's interesting. This is on ARS Technica, and I'll leave a link below for you for this. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also
help
the young generation with university tuition and the community around our church. Thank you.